Graphing a piecewise defined function, problem type 3. Suppose that the function f is defined for all real numbers as follows. Here's the function f of x, and here are the three pieces, each with a respective domain. Okay, there's a domain here for the first piece, there's a domain here for the second piece, and there's a domain here for the third piece. We're going to go ahead and try to graph this function, and we're going to label key points along the way. If you have graph paper, that certainly helps. And if you have a straight edge, that may help as well. Let's draw some graph paper here. And what else we got? So there's a set of axes. Let's graph x squared plus 1. X squared plus 1. That is a basic parabola shifted up 1 unit. So how many units am I going to need? It looks like I need 7 units going up. 1, 2, 3, 4, 5, 6, 7. So 7 units going up, and we're going to graph a parabola going up on the domain of what? X less than 1. So we need a 1 here, and we know the y-intercept for that parabola is actually 1. So we're going to see that here. And then when x is 1, it does yield a 2, but that 2 is actually a hollow dot because the domain does not include the input value of x equals 1. So we have a nice upward facing parabola going this way. So that's the first piece. The second part of the function says the output value is 2 when the input value is 1. The output value is 2 when the input value is 1. Why don't we write that with this, with a different color there. So when x is 1, the output value is 2. So now we fill that part in. The last piece is actually a straight line. I'm going to draw the last piece first as a dotted line. So why don't we draw that as this color. So the y-intercept is 7. And then it's down 5 and right 1. Down 5 and right 1. 1, 2, 3, 4, 5, and right 1. So looks like I want to need a straight edge this time. So let's bring a straight edge back. Rotate my straight edge here. And I'm going to need to draw this first dotted. Well, it says x is greater than 1. Why don't we not draw it dotted? Why don't we actually finish the appropriate domain? So there's actually a piece here, like that. So there's 3 pieces here. The first piece happens to be in red, the second piece happens to be in blue, and the third piece happens to be in green. Let me erase that unnecessary marking there. Erase that. Okay. So there's the graph of the 3 pieces, each with their own appropriate domain. It is a function. It passes the vertical line test. For every x, there's exactly 1 y. And we got to determine, is this continuous or not continuous? So to determine if it's continuous or not, what you want to do is take a pencil and see if you could trace the function from left to right without ever lifting it up. And we can. I don't have to lift up this lightsaber ever as I'm tracing it. So once again, if I'm tracing it from left to right, and if I don't have to lift up this lightsaber, it's continuous. All right.